Welcome to our comprehensive guide on testing interview questions for software quality assurance. Today, we'll explore the essential concepts that every software tester and quality assurance professional should master. Software testing is a critical discipline that ensures applications work correctly and meet user expectations. The topics we'll cover include test-driven development, various testing types, popular testing frameworks, and quality assurance practices. These are fundamental areas that interviewers frequently focus on when hiring testing professionals. Understanding these concepts will give you the confidence to tackle any testing interview successfully. Test-driven development, commonly known as TDD, is a software development methodology where tests are written before the actual code. The TDD cycle follows three simple steps, often called red, green, blue. First, write a failing test. This is the red phase where your test fails because the functionality doesn't exist yet. Second, make the test pass by writing the minimum code required. This is the green phase. Finally, refactor the code to improve its structure while keeping tests passing. This is the blue phase. TDD offers significant benefits including better code design, reduced bugs, living documentation that stays current with your code, increased confidence when making changes, and surprisingly faster development once you master the technique. Let's look at a practical TDD example using a simple calculator function. The test structure follows the arrange, act, assert pattern. In the arrange phase, you set up your test data by creating a calculator instance. In the act phase, you execute the function you want to test, calling the add method with parameters 2 and 3. In the assert phase, you verify the expected result equals 5. Initially, this test will fail because the calculator class and add method don't exist yet. This is the red phase of TDD. The failing test guides you to write exactly the code needed to make it pass, ensuring you don't over-engineer solutions. Software testing is broadly categorized into two main types: functional and non-functional testing. Functional testing verifies that the software behaves according to specified requirements. It includes unit testing, which tests individual components in isolation, integration testing that verifies components work together correctly, system testing that validates the complete system, acceptance testing that ensures the system meets business requirements, and regression testing that confirms existing functionality still works after changes. Non-functional testing evaluates aspects like performance, security, and usability. This includes performance testing to measure speed and scalability, security testing to identify vulnerabilities, usability testing to ensure good user experience, compatibility testing to verify the software works across different environments, and load testing to assess system behavior under expected user loads. Unit testing follows the first principles, which are 5 key guidelines for writing effective tests. Fast means your tests should run quickly, typically in milliseconds, allowing frequent execution during development. Independent means tests should not depend on other tests or external systems. Each test should be able to run in isolation. Repeatable means tests should produce the same results every time they run, regardless of environment or execution order. Self-validating means tests should have clear pass or fail results without requiring manual interpretation of outputs. Timely means tests should be written at the appropriate time, ideally before or alongside the production code, not as an afterthought. These principles ensure your unit tests are reliable, maintainable, and provide real value to your development process. Integration testing verifies that different software components work correctly when combined. There are several approaches to integration testing. Big Bang integration combines all components simultaneously and tests the entire system at once. This approach is simple, but makes debugging difficult when issues arise. Incremental integration adds components one by one, making it easier to isolate problems. Top-down integration starts from the highest-level modules and progressively adds lower-level components, using stubs to simulate missing modules. Bottom-up integration begins with the lowest-level modules and builds upward, using drivers to test components. Testing strategies include stubs, which are dummy modules that simulate lower-level components during top-down testing, drivers, which are test harnesses that call and test individual modules during bottom-up testing, and the sandwich approach, which combines both top-down and bottom-up strategies. Several testing frameworks dominate the software testing landscape. Pytest is a powerful Python testing framework that offers fixtures for test setup, parametrization for running tests with different datasets, and an extensive plugin ecosystem. Unittest is Python's built-in testing framework that provides test cases, test suites, and comprehensive assertion methods. It's always available but less feature-rich than Pytest. Selenium specializes in web automation and UI testing, allowing you to control browsers programmatically and simulate user interactions. Jest is JavaScript's most popular testing framework, offering built-in mocking capabilities, snapshot testing for UI components, and code coverage reporting. Each framework has its strengths: pytest for Python unit tests, Selenium for web testing, and Jest for JavaScript applications. Quality assurance encompasses systematic activities that ensure software meets specified requirements and quality standards. Core QA activities include code reviews, where team members examine each other's code to catch issues early and share knowledge. Static code analysis uses automated tools to identify potential bugs and code quality issues without executing the program. Continuous integration automatically builds and tests code changes, providing immediate feedback to developers. Test automation reduces manual effort and ensures consistent test execution. Risk assessment identifies potential project risks and their mitigation strategies. Documentation standards ensure that requirements, designs, and procedures are clearly recorded. Key QA metrics include defect density, which measures bugs per lines of code, test coverage showing the percentage of code tested, defect removal efficiency indicating bugs found before production, and mean time to resolve, measuring how quickly issues are fixed. Testing interviews typically focus on several key areas. Common questions include explaining the difference between unit and integration testing. Unit tests verify individual components, while integration tests check how components work together. Interviewers often ask about the TDD process and its benefits, expecting you to describe the red-green-blue cycle and advantages like better design and fewer bugs. Handling flaky tests is another frequent topic. These are tests that sometimes pass and sometimes fail, requiring investigation and stabilization. The testing pyramid concept describes having more unit tests at the base, fewer integration tests in the middle, and minimal end-to-end tests at the top. Measuring test effectiveness involves metrics like code coverage, defect detection rate, and test execution time. When answering, structure your responses with clear examples. Share specific tools and frameworks you've used, discuss challenges you've faced and how you solved them, and mention industry best practices and relevant metrics. Let's summarize the essential points for testing interview success. Technical excellence requires mastering TDD fundamentals, including the red-green-blue cycle, and understanding when and how to apply it effectively. You should understand different testing types and when to use each one. Unit tests for individual components, integration tests for component interactions, and system tests for end-to-end validation. Familiarity with appropriate frameworks like pytest for Python, Selenium for web testing, or Jest for JavaScript is crucial. Writing maintainable tests that follow the first principles ensures long-term value. Quality processes involve implementing systematic QA practices, including code reviews, static analysis, and continuous integration. Track meaningful metrics that provide insights into software quality, not just vanity numbers. Embrace continuous improvement by regularly reviewing and enhancing your testing approaches. Foster team collaboration because quality is everyone's responsibility, not just the testing team's. Remember, quality is not an act, it is a habit. Build testing into your development culture from the beginning and make it an integral part of how your team delivers software.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.